Hello again, class. We'll now look at question 4 on page 3 of the Solving Simultaneous Linear Equations in Two Variables by Elimination Method, worksheet 5.4. For this question, we see two equations that involve fractions. The method to work this out is still the same, so let us go through them one by one. In step 1, we'll arrange the variables in the equation in the order of x, y, and the constant. So in these two equations, we can see that it is already in that format. We have x term, y term, and the constant term on the right hand side of the equation. So once we're done with that, we can label the two equations 1 and 2. In the next step, we're going to identify one variable to be eliminated. I'm going to choose to eliminate my x variable. So right now we have to make the coefficient the same. To do so, we're going to change the fractional coefficients into integers so that they are easier to work with. So to do so, let's look at equation 1. If I want to get rid of my denominator of 6, what I'll need to do is to multiply by 6 to it. So I'm going to multiply 6 to the whole equation. So when I multiply 6 times x over 6 will leave me with only x. As for 6 times y over 3, it will give me 2y. Lastly, on the right hand side, I'll use 4 times 6, which will give me 24. Once you're done with this, remember to label your equation. Now let's look at equation 2. I have a denominator of 12 for my term x here. So what I'm going to do is to multiply this whole equation by 12, and that will give me x plus 8y. If you're not too sure how to get 8y, you basically use 2/3 multiply by 12. You can use your calculator to calculate this. And on the right hand side, I will have 4 multiplied by 12, which will give me 48. Remember that when you multiply the equation, you must do so to the left hand side and the right hand side. All the terms must be multiplied. So next, we are going to eliminate the variable with the same coefficient. Now we can see that x now has the same coefficient, and because they are both positive, I'm going to use equation 4 to minus away equation 3. So equation 4 minus equation 3 will give me x minus x, looking at the x terms in the first row, followed by 8y minus 2y, and on the right hand side, I'll have 48 minus 24. You may ask, why do I not choose equation 3 minus equation 4? Normally, I will try to get a positive number, so I will use the bigger number to minus away the smaller number. But it is your choice. If you use equation 3 to subtract equation 4, it will still get you the answer ultimately. So with this, I can cancel out the two x's, and I'll be left with 6y equals to 24. So now we can solve for our y, which will give us 4. So now that we have y equals to 4, we are going to put it back into equation 3. Okay, so from equation 3, we have x plus 2y equals to 24. So now we know that y is 4. We will have x plus 2 multiplied by 4 equals to 24. Working this out, we have 24 minus 8, because when you bring it over to the right hand side, your sign changes. And you'll find out that x is actually equals to 16. Do not forget to check your answers. Substitute x equals to 16 and y equals to 4 into both the equations. Check that the left-hand side balances out with the right-hand side. Once you have that, you know that your answer is correct. Hence, your answers for this question will be x equals to 16 and y equals to 4. For this topic of solving simultaneous equations, please make sure that you follow the presentation properly. It is important that you label your equations and show your steps. Do not miss out any workings and make sure that you check your answers at the end.